Very good afternoon, children. The next topic is Lenz law. Next topic is Lenz law. A German physicist, Heinrich Lenz, performed a series of experiments on electromagnetic induction. So, series of experiments on electromagnetic induction, and they deduce a law of determine the direction of the induced current. This law is known as Lenz law. Lenz law state that this is a very important 2 mark question. Please note it down. Lenz law state that the direction of the induced current in such that it always opposes the cause responsible for its protection. Once again repeat, Lenz law states that the direction of the induced currents is such that it always opposes the causes responsible for its protection. Faraday discovered that whenever magnetic flux linked with a coil changes, an electric current is induced in the circuit. This is the statement of Faraday's law. But here, this magnetic flux change is the cause, while the induction of the current is the effect. Lenz law says that the effect always opposes the cause. Once again repeat, Lenz law says that the effect always opposes the cause. Therefore, the induced current would flow in a direction so that it could oppose the flux changes. The induced current would flow in a direction so that it could oppose the flux change. The next point is, by incorporating Lenz law into Faraday's law, the equation 4.2 is rewritten as epsilon is equal to minus of d into n phi b divided by dt. The negative sign signifies that the direction of induced EMF is such that it opposes the change in magnetic flux. To understand Lenz law, let us consider two illustrations in which we find the direction of the induced current in a circuit. What are the illustration? Illustration 1. Consider the uniform magnetic field. This is the uniform magnetic field. The cross symbol indicated the uniform magnetic field acting inward or perpendicular to the plane of the paper. Acting inward, pointing inward, perpendicular to the plane of the paper. Here, uniform magnetic field with its field lines perpendicular to the plane of the paper and the pointing inward. These field lines are represented by crosses. These crosses as shown in the figure. A rectangular metallic frame. This is the rectangle metallic frame A, B, C, D. In this magnetic field, with its plane perpendicular to the field, the arm AB is movable so that it can slide towards right or left. This is slide, moves towards to right or left. What happens when we move towards to right? The magnetic lines of force, that the magnetic field, maximum magnetic lines of force passing through this rectangular frame. When we move towards to left hand side, minimum amount of magnetic field passing through this rectangular frame. So that is why the field, that means field lines, magnetic field lines changes due to the moving of slide towards to right or left. So whenever there is any changes in magnetic field lines, means it is automatically produce the current. So here, if the arm AB slide to our right side, the number of field lines, magnetic flux passing through the frame ABCD increases and a current is induced. As suggested by Lenz law, the induced current opposes this flux increases and it tries to reduce it by producing another magnetic field pointing outwards, that is opposite to the exciting magnetic field. The magnetic lines of this induced field are represented by red colored, here red colored circle in the figure. From the direction of the magnetic field thus produced, the direction of the induced current is found to be anti-clockwise by using right and thumb rule. The next, if suppose the slide moving in a leftward motion of the arm AB decreases the magnetic flux, here left side movement means which is decreases the magnetic field. What happened? Decreases the magnetic flux. The induced current this time produce the magnetic field in the inward direction, red color cross, that is the in the direction of the exiting magnetic field. Therefore, the flux decreases is opposed by the flow of induced current. From this, it is found that induced current flows in clockwise direction. Then, illustration 2. Let us move a bar magnet towards to the solenoid. Here, bar magnet move towards to the solenoid. Solenoid means a longly wound, closely wound helical coil is nothing but solenoid. So let us move the bar magnet towards to the solenoid. What happened with its north pole pointing the solenoid? This motion increased the magnetic flux of the coil, which in turn induced an electric current. So this is the bar magnet. Move towards to the coil, that means solenoid. What happened? More number of magnetic lines of force contact with or passing through this coil, that is a solenoid. So which is make a magnetic field. So when the current flow through the coil due to the magnetic lines of force contact with this solenoid. So this motion increased the magnetic flux of the coil, which in turns induced an electric current. Due to the flow of induced current, the coil becomes a magnetic dipole whose two magnetic poles are on either end of the coil. In this case, the cause producing the induced current is the movement of the magnet. According to Lenz's law, the induced current should flow in such a way that it opposes the movement of the north pole towards the coil. It is possible if the end near to the magnet becomes north pole. Here, nearer end north pole. The next point is then it repels the north pole of the bar magnet and opposes the movement of the magnet. Once pole ends are known, the direction of the induced current could be found by using right and thumb rule. When the bar magnet is withdrawn, the nearer end becomes south pole, which attracts north pole of the bar magnet, here away from the solenoid, opposing the receding motion of the magnet. Thus, the direction of the induced current can be found from Lenz's law. Once again repeat, then it repels the north pole of the bar magnet and opposes the movement of the magnet. Once poles ends are known, the direction of the induced current could be found by using right and thumb rule. When the bar magnet is withdrawn, the nearer end becomes south pole, which attracts north pole of the bar magnet, opposing the receding motion of the magnet. Thus, the direction of the induced current can be found from Lenz's law. Once again repeat the statement of Lenz's law. Lenz's law states that the direction of the induced current is such that it always opposes the cause responsible for its protection. Lenz's law says that the effect always opposes the cause. Therefore, the induced current would flow in a direction so that it could oppose the flux changes. Once again repeat, the induced, that the direction of the induced currents is such that it always opposes the cause responsible for its protection. This is the statement of Lenz law. Thank you.